Hi, my name is Noadina binti Aini, and I would like to introduce about IR preamp circuit. Okay, IR preamp circuit are used as the sensing elements at the receiver end of light beam alarms, remote control, or fiber optic cable systems. In such applications, the signal reaching the photosensor may vary considerably in strength, and the sensor may be subjected to a great deal of noise in the form of unwanted visible or IR-like signals. The systems are usually operate in the IR range, and the optosensor output is passed to processing circuitry with a low noise preamplifier with a wide dynamic operating range to help minimize the problem.
Okay, so this is the circuit. This figure shows the example of circuit using photodiode sensors. The circuit is designed to detect an IR optical signal that is switched at a 30 Hz rate. Photodiode D1 sends the IR signal and feeds it into 30 Hz tuned circuit L1, C1, C2, which is slightly damped by R1. The resulting frequency selected low noise output of the tuned circuit is tapped off at the C1, C2 junctions and then amplified by Q1.
Okay, this circuit also consists three components, which is resistor, capacitor, and inductor. Okay, for resistor. Resistors are also be used to provide a specific voltage to an active device such as a transistor. And for capacitor, to prevent the DC signal from occurring on the output device, a coupling capacitor is added in series with the load. Coupling capacitors are essential components in amplifier circuits. They are used to prevent interference of a transistor's bias voltage by AC signals. However, for the inductor, it is to prevent amplifier oscillation when driving difficult loads that have high capacitance. Okay, that's all from me for introduction.
Hi, I'm Azria Kushairi bin Yusuf from BE1 over 2 to demonstrate a simulation about IR pre-amplifier circuit. IR pre-amplifier circuit is functioned as the sensing element at the receiver end of light beam alarm, remote control or fiber optic cable system. It sends the IR signal and feed into 30 kHz tuned circuit by L1, C1, and C2, which is slightly damped by R1. The result frequency selected low noise output of the tuned circuit is tapped off at the C1 and C2 junction and amplified by Q1. Here I want to show how the signal sent from the remote or other S device. Here the output. When the signal sends and then when the off sends.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haikal Daniel bin Arifin and my magic number is B0819102886. And now I want to present my part, that is analysis and result. IR preamp circuit is a circuit that receives a signal from transmitter such as remote control television. When the user presses the remote control button, the transmitter sends a signal to the decoder as a receiver, such as the decoder Astro or the receiver at television itself. The main component in this circuit is photodiode. Photodiodes are often used as the sensing elements at the receiver end of light beams alarms, remote control or fiber optic cable systems. In such applications, the signal reaching the photosensor may vary considerably in strength, and the sensor may be subjected to a great deal of noise in the form of unwanted visible or IR-like signals. To help minimize this problem, the systems are usually operated in the IR range, and the optosensor output is passed to processing circuitry via a low noise preamplifier with a wide dynamic operating range. So this is diagram of figure of circuit that we construct for IR preampere circuit. This is voltage supply with 12 volt, and this is switch SPDT, single pole double throw, and this is LED IR representing a photodiode, resistor. This is inductor, capacitor. This is transistor, and this is oscilloscope to display output. From the circuit diagram above, the circuit operates with 12 volt voltage supply. The current will flow to LED IR as photodiode with 33.847 mA by using simulation multisim. When the switches are closed, the current can flow to LED IR. The current flow into the LED IR means the signal from transmitter device are going to the receiver. Based on the square graph, the graph turn to high means the receiver receive the current signal, and otherwise, if no signal, the graph turn to low. For example, when the user press the button of remote control, so the switch from open will be closed, and the signal will be through here, and then will be received by LED IR. When LED IR turn to on or light, that means the receiver already received the signal from transmitter. When user press the button at this condition is 0 or low, and when when user press the button, the signal will be received by receiver, and at here it becomes high. And when the signal already do not accept or received by receiver, it become low. The circuit is designed also to detect an IR optical signal that is switched at a 30 kHz rate. LED IR sends the IR signal and feeds it into 30 kHz tuned circuit L1, C1, C2, which is likely damped by R2. The resulting frequency selected low noise output of the tuned circuit is tapped off at the C1, C2 junction and the amplifier by Q1. Thank you very much.
Hi, my name is Tengku Nur Nadira binti Tengku Kamarul Bahrim. I'm pretty sure that doctor have been looking through for our simulation and circuit. So I'm going to explain about the discussion. Okay, the IR receiver is looking for infrared light, which is 980 nanometer range that is passing at around 30 kHz. The IR remote sends short bursts of 30 kHz infrared light in a different on-off pattern for each button on the remote, while the IR receiver burst it sends a 0 to input or output pin and a 1 when it does not. The infrared receiver needs 3 connections, which is 12 volt, ground, and input or output pin to read the signal it sends. The circuitry inside the infrared receiver make it safe to connect each signal pin to input or output pin with a small resistor, even though the sensor is powered by 12 volt. It performs the function of an IR transmitter which sends pulse IR rays after modulating the original signal with a carrier of 30 kHz frequency. These signals are received by IR receiver. These are designed to receive signal of only 30 kHz. It sends the received output and demulates them. Therefore, original signals are retrieved after demulation. The output from the receiver is then sent to microcontroller. It decodes the signal from the IR receiver and it recognizes the device to be function. The input and output are controlled. The decoded output from the microcontroller is obtained by the relay. When a 12-volt input is applied to any of the input pins, which is 1 to 8, output voltage at corresponding output pin, which is 11 to 18, drops down to 0, providing ground from the external circuit. The external circuit gets grounded at one end while it is provided positive VCC at its other end. So, the circuit gets complete and start operating. A total of 6 relays are connected to the output pins. When the relay gets excited from the outputs appearing at the IC pin, it gets active. The IR signal from the transmitter is detected by a IC with an integral photodiode and is amplified, filtered, and demulated so that the receiving device can act upon the received command. Okay, as for the conclusion, IR sensors are highly susceptible to ambient light and the IR sensor on the sensor is suitably covered to reduce effect of ambient light on the sensor. The on potentiometer should be used to calibrate the sensor. An infrared light emitting diode, which is IR LED, emit lights of infrared range 700 nanometers to 1 millimeter. There are two types of infrared sensor, which is active and passive. Active infrared sensor both emits and detect infrared radiation. Active IR sensor have two parts, which is LED and receiver. When an object comes close to the sensor, the infrared light from the LED reflects off the object and is detected by the receiver. Active IR sensor as a proximity sensor, and they are commonly used in obstacle detection systems such as in robot. So that's all from me.